So our lab's research focuses on biomarkers for psychiatric disorders, and if you don't know what those are, I will be explaining them. Originally I was asked to do a talk on the use and validity of biomarkers for males and females with applications in Asperger syndrome, but since this is the topic of my PhD, I'm going to be expanding this to other psychiatric conditions as well. So a background first is important. Mental disorders are extremely prevalent, with between 18 and 36% of the world's population developing a mental disorder in their lifetime. And these, together with neurological and substance use disorders, comprise 13% of the total global disease burden, which is defined as the impact of a health problem as measured by financial cost, mortality, and morbidity. Furthermore, a high proportion of individuals suffering from severe psychiatric disorders don't ever receive treatment, even in high-income countries. And then in addition to causing suffering at an individual and community level, mental disorders are also extremely expensive, and it's estimated that they will cause a cumulative global loss in economic output of $16.3 trillion over the next 20 years. So then from a medical perspective, what leads us to this current picture of mental health? And we'll take a brief look at two problem areas, which are diagnosis and treatment. So diagnosis of mental illness and developmental conditions is through interview by a psychiatrist using the International Classification of Diseases, or Diagnostic and Statistical Manual of Mental Disorders. And although diagnosis of mental conditions has come a long way, it's now less subjective than it used to be. It's standardized and interviews are more structured. We can't get away from the fact that it's still based on symptoms and not the underlying biological cause of the illnesses. And this is further complicated by the fact that psychiatrists are faced with patients having a set of heterogeneous symptoms that don't fit neatly into one category of illness. These illnesses often have no single defining feature. Patients often have multiple illnesses, and illnesses often have overlapping symptoms, which incidentally also makes them very difficult to study from a scientific perspective. And then a second problem is with treatment of mental illness. Two huge classes of drug used to treat psychiatric conditions are antipsychotics and antidepressants. And in terms of antipsychotics, we see that 30% of patients using them don't improve with their use. Many discontinue use, and the side effects can be severe. Antidepressants have their own set of related issues. It's been reported that they may be ineffective in cases of mild depression, and they can take weeks for symptom improvement, and maybe more if different doses and different medications need to be tried. And this is a situation that may not improve anytime soon, as we see that pharmaceutical companies are abandoning drug discovery in neuropsychiatric disorders. So this paints a pretty sad picture. So we will go into some current research aimed at working towards some solutions. The National Institute of Mental Health in the US illustrates the different types of research being done in mental illness and where they're going in terms of improving patient lives, at least in the ideal case. In our lab, we focus on clinical proteomics, which involves taking blood from patients and healthy subjects. We then measure the concentrations of hundreds of different molecules in the blood, which are proteins for the most part, and test whether the concentrations of these molecules are different between the patient and healthy groups. And if they are, this can help us in two ways. So first, it can tell us something about the disease mechanism. And second, it can help us to diagnose patients, treat them, and monitor them. For example, if we find a molecule that becomes elevated just prior to a psychotic episode in schizophrenia, we can use that molecule to monitor it and put in preventative measures. And we would call this molecule a biomarker or a marker. One question that we often get asked is how can you investigate a brain problem by looking at the blood? Well, first of all, we can't take brain samples from living patients, so that's a limiting factor. And second, we know that the brain and body interact, and we actually see this in theories of mental illness. So a number of these are broadly classified as genetic, neurochemical, endocrine, and infectious or immune theories, many of which can be investigated by studying the body and not necessarily just the brain. But whether we study the brain or the body, we're still left with this problem of clinical heterogeneity, and this is often reflected in the findings from investigations of these theories, so that we really have no clear understanding of how these conditions develop. And so what we wanted to do was to take a look at an often neglected part of this heterogeneity, and that's sex. And this heterogeneity is not only neglected in human studies, but also in studies of preclinical models, which is a nice word for rat or mice studies, and cellular models, as we heard about yesterday. And so the idea here, though, is that if we can untangle some part of the heterogeneity of these conditions, we can start to understand them in males and females and provide better treatment for each of the sexes. So then, as I alluded to in the last slide, from a clinical perspective, there are sex differences in a number of different aspects in psychiatric illnesses, including in manifestation, prognosis, and prevalence. And in my research, I focused on a few conditions with prominent clinical sex differences that I'll describe briefly here. We see that in Asperger syndrome and other autism spectrum disorders, which are characterized by difficulties with social interaction and repetitive patterns of behavior, there's a greater male prevalence, about 4-to-1 male to female ratio. And in depression and anxiety, characterized by low mood and other physical symptoms, we see a greater prevalence in females with these conditions, and this ratio is about 2-to-1 female to male. And finally, in schizophrenia, which is a severe psychotic disorder, we see that females generally have an older age at onset, a better course of illness, especially prior to menopause, and generally a better response to antipsychotic medication. So if we see this kind of heterogeneity at the clinical level, can we also see this at the molecular level and thereby gain some insight into the biology behind these sex differences? And so to do this, we looked at a number of patient groups. And for each of these patient groups, as I described before, we measured the concentrations of hundreds of different molecules in their blood. In schizophrenia, we looked at 133 patients and controls. In Asperger syndrome, we looked at 30 patients and 29 controls. And in depression, we looked at 199 patients and 365 controls. And these were from centers across Europe, in Cambridge, the UK, in Germany, and in the Netherlands. So then for each condition, we will look at a couple of things. First, we'll look at analytes for which sex-specific changes in concentration occur in the condition. And second, we'll look at what role those sex-specific markers may play in classifying each of these conditions. So we'll start off with Asperger syndrome. And so this chart here illustrates molecules whose concentrations were changed only in either males or females with Asperger syndrome. So these are sex-specific markers or biological indicators of Asperger syndrome. And in the left column, you see female-specific markers of Asperger syndrome, and they're indicated by the abbreviations for the different molecules, together with the direction of change in concentration. And on the right are male-specific markers of Asperger syndrome, and these molecules are grouped into different biological functions. And from this, we can make a few different observations. So in Asperger syndrome, we found a number of female-specific markers involved in lipid metabolism, and previous studies have found that a number of conditions that are characterized by impaired lipid metabolism also see an increased incidence in autism spectrum conditions. We see also that there are likely elevated levels of free testosterone in females with Asperger syndrome, as indicated by lower levels of sex hormone binding globulin, which may be important in altering brain development and contributing to disease onset. And then finally, we found elevated levels of certain inflammatory molecules, specifically in males. And increased levels of inflammatory molecules are prominent in several psychiatric disorders and have been associated with the breakdown of the barrier between the body and the brain. And they can also interfere with signaling in the brain. So our findings suggest here that there may be some kind of male-specific component to this phenomenon as well. So then, as I mentioned before, biomarkers are not only useful for gaining insight into potential disease mechanisms, but they can also potentially help us to classify some of these very complicated disorders. And in this instance, we've constructed an algorithm using the measured molecules to try and classify males and females with Asperger syndrome. So in these plots, this is a receiver operating characteristic curve, or ROC curve, and we use these to visualize the performance of our classification algorithm. In a ROC curve, we vary the threshold of our algorithm, which changes the sensitivity and specificity of our classification. And as you may know, sensitivity here would be the fraction of individuals with Asperger syndrome correctly classified. We see this on the vertical axis. Sensitivity would be the fraction of controls correctly classified, and this is on the horizontal axis. And we use the area under the curve, or AUC, of this ROC curve as a measure of the accuracy of our classification algorithm, with an AUC of 1, meaning the algorithm classifies everyone perfectly. And we would see this when the line is up in the left-hand corner, where we have perfect sensitivity and specificity. And an AUC of 0.5, we see this as a diagonal line going across the plot, meaning that the algorithm is about as good as a random chance at classifying. And in general, we say that a classifier with an AUC of between 0.9 and 1 is excellent, between 0.8 and 0.9 is good, and so on down to about 0.6, where we say this is not particularly diagnostically useful because we're getting pretty close to guessing. And here we see that sex is very important in constructing a classifier for Asperger syndrome. So in the top plot there, when we see that when we construct a classifier using only females, it performs very well at distinguishing female Asperger syndrome from controls. That line is in red, but fails to classify male Asperger syndrome from controls. And the same is true for a classifier constructed using only males. So here it performs fairly well in the males, that's the black line on the bottom. And again, using this same classification algorithm to try and classify females, we see that it completely fails to do so. And this was true using our drug-free cohort and also when including patients using psychiatric medication. And this finding is something that would be quite easy to miss if we don't recruit our participants with great care. As I said before, Asperger syndrome is about 4 times more prevalent in males. So then we'll move on to schizophrenia. And a number of female-specific markers of schizophrenia were related to blood vessel development, which may be relevant as changes in blood flow abnormalities are associated with symptoms of schizophrenia. In addition, as in Asperger syndrome, we see elevated levels of testosterone, specifically in females. And again, we see that as in Asperger syndrome, most of the male-specific markers were related to inflammation and were elevated in individuals with schizophrenia compared to healthy subjects. Here, however, unlike in Asperger syndrome, we have several strong overall predictors of schizophrenia, so that sex is not quite as important when we look at classification of the disorder. And we can see from this that classifiers built on male and female data together are just as good as classifiers built on male and female data separately. And also, although I haven't shown it here, unlike in Asperger syndrome, male classifiers, so classifiers built only on male data, are quite effective at classifying female data and vice versa. So finally, we'll look at major depressive disorder. And again, as we saw in Asperger syndrome and schizophrenia, male-specific markers of depression were elevated and related to inflammation and immune function. And so we've seen this across many psychiatric disorders at this point. And this male-specific elevation in inflammation markers may arise due to sex differences in how the psychiatric disorders are caused, how the disorder manifests, or how the body copes with the disorder. But this is something for further studies to investigate. And here we found few female-specific markers of depression. And we see that, again, as in Asperger syndrome, sex is important when we construct a classifier for depression. Unfortunately, using the measured molecules, we're unable to predict female depression. But we can predict male depression with an accuracy greater than chance. We see an AUC of 0.64, although we still have a long way to go before we have a diagnostically useful test for depression for either males and females. And this is potentially because of the particularly heterogeneous nature of depression. So now we've looked at sex-specific markers for schizophrenia, Asperger syndrome, and depression, as well as how they affect classification of conditions. So what does this really mean for the future of the field of psychiatry? Well, our findings have fairly wide-reaching implications for the way we study and treat these conditions, as we've seen that there is evidence for sex differences in how they present themselves biologically in males and females, and therefore potentially in how they develop and in how they should be treated. And this should be a subject area to actively pursue, both in order to more fully understand disease mechanisms in males and females, and also to develop more effective therapies for them as well. And as we progress in this area, develop diagnostic tests or patient monitoring devices based on biomarkers, these findings show that sex will likely continue to be something that we need to keep in mind, as this may determine the success or failure of a biomarker product. And I'd like to illustrate this just by providing a potential future vision of psychiatry or other fields of medicine, and that's one of personalized medicine. So it's where we start with a patient group, and instead of diagnosing and treating them all in the same way, we stratify the group in order to diagnose and treat them better. So this stratification could be according to sex, as we've explored, age, ethnicity, and potentially other important demographic and lifestyle variables, together with a personal biomarker signature and more traditional diagnostic tools like psychiatric interviews. These may help to determine what type of condition these patients have, what type of treatment they will respond well to, and even predict potential relapses. And of course, this is a vision and not reality yet. But for it to become reality, we will need bigger, better characterized cohorts with patients at earlier stages of their conditions. And this is something that our lab, in collaboration with others in Europe and in North America, is working to achieve, so that hopefully soon we'll see some biomarker products out there to aid psychiatrists in diagnosing and treating these very complicated conditions. So thanks for listening. Finally, I'd like to acknowledge the Bond Lab, and in particular my supervisor, Sabina Bond, together with our collaborators, funders, and especially the patients and controls for their selfless donations, without whom these studies would not have been possible. And then here I've listed some potentially relevant publications in case this is something you'd like to explore in more depth. So thank you very much.